Welcome to episode 52, Protecting Networks with Cloud Armor. In today's connected world, every public-facing application carries inherent exposure to the Internet's unpredictable traffic. Attackers automate scans, launch denial-of-service floods, and probe for weaknesses continuously. The guiding mindset for network security is therefore exposure minimization, allowing only the necessary access while observing, filtering, and adapting to evolving threats. Google Cloud Armor provides this defensive capability at global scale. It acts as a protective shield in front of applications, filtering malicious traffic before it reaches back-end systems. Cloud Armor combines network engineering, intelligent analysis, and policy-driven controls into a single managed service. Its mission is simple yet powerful: to protect availability, integrity, and user experience without introducing friction or latency that would slow legitimate traffic. The strength of Cloud Armor begins with its Anycast edge and globally distributed defense model. Google's network has points of presence across the world, each capable of absorbing and filtering large volumes of requests before they approach an organization's infrastructure. By deploying protection at the edge, Cloud Armor reduces latency for legitimate users and intercepts malicious traffic early. This global footprint is particularly valuable for mitigating volumetric attacks like distributed denial-of-service events, which depend on overwhelming capacity. When an attack begins, traffic is automatically routed to the nearest point of presence, where filtering rules immediately engage. This distributed model transforms defense from a reactive posture into a resilient, pre-positioned shield that scales alongside the Internet itself. Cloud Armor specializes in Layer 7, or L7, protection, defending the application layer where user requests meet business logic. Its Web Application Firewall, or WAF, interprets incoming HTTP and HTTPS traffic to detect suspicious patterns such as injection attempts, malformed headers, or exploit payloads. Administrators can apply customizable rule sets to block or allow requests based on attributes like path, method, or signature. For example, a rule might block requests containing known SQL injection patterns or disallow outdated user agents. Layer 7 protection goes beyond simple packet inspection. It understands context and intent. This intelligence keeps applications responsive while filtering harmful or wasteful requests at the first point of entry. Managed rules simplify security for common web vulnerabilities without requiring custom configuration. Google provides regularly updated rule sets that address threats such as cross-site scripting, command injection, and directory traversal. These managed policies reflect global intelligence gathered across the ecosystem, ensuring protection evolves alongside attackers' methods. Administrators can enable them selectively, tuning thresholds to balance protection and false positives. For instance, enabling the OWASP core rule set provides immediate coverage for the most widespread web risks. Managed rules remove the burden of manually maintaining detection patterns, letting teams focus on business logic rather than on constant threat signature updates. This automation keeps defenses current and consistent across environments. Adaptive protection introduces a dynamic layer of intelligence within Cloud Armor. It uses machine learning to identify unusual traffic patterns that may indicate emerging attacks. By learning normal behavior for each protected service, adaptive protection can alert operators or automatically apply rate-limiting rules in response to anomalies. Imagine a sudden surge of requests from a narrow set of IP addresses or an unusual country pattern. Adaptive protection can detect and mitigate it before it impacts availability. These capabilities bridge the gap between static rule-based defenses and real-world unpredictability. The system continues learning over time, refining its baselines to improve both accuracy and responsiveness without constant human tuning. Rate limiting and bot mitigation form another cornerstone of network defense. Rate limiting restricts how frequently a single client or group of clients can make requests, reducing the risk of abuse and resource exhaustion. Bot mitigation differentiates between legitimate automated services like search engines and harmful scrapers or brute force attackers. Cloud Armor policies can combine both, allowing known good bots while throttling unknown or suspicious sources. For example, a retailer might use rate limiting to protect its checkout endpoint during peak events, ensuring human users always receive priority access. These controls transform defensive posture from binary blocking to intelligent traffic management, aligning protection with user experience. Geo-controls and allow or deny lists help organizations enforce geographic or source-based restrictions aligned with business needs. CloudArmor lets administrators define rules that permit or block requests based on originating countries, IP ranges, or specific networks. This can reduce exposure by limiting access to regions where customers operate and excluding areas associated with persistent attacks. For instance, a government portal serving only domestic users can restrict traffic to its home country, instantly filtering out irrelevant or risky sources. Allow and deny lists also enable rapid response during incidents, isolating malicious actors without disrupting legitimate users. Geography becomes an operational lever for strategic exposure management. CloudArmor integrates seamlessly with Google Cloud's load balancers and back-end services, forming a unified traffic management layer. When a request enters through a global load balancer, CloudArmor evaluates it against active security policies before forwarding it to the appropriate application. This integration provides defense without redesigning architectures. Developers can define policies at the same layer they already use for routing and scaling. For example, an application served through an HTTPS load balancer can gain full CloudArmor protection simply by linking an existing policy. This synergy ensures that network security and traffic delivery function as complementary parts of a single pipeline, not as disconnected tools. Tuning security signals requires visibility and feedback loops. CloudArmor integrates with cloud logging, security command center findings, and cloud monitoring dashboards. Logs provide granular data on allowed, denied, and rate-limited requests, helping administrators refine policies. Visualization tools display trends over time, revealing which rules trigger most frequently and where false positives may occur. Analysts can correlate these insights with upstream or downstream system metrics to understand full impact. For example, if a rule triggers repeatedly during a marketing campaign, tuning thresholds may balance protection with accessibility. This observability ensures that security evolves intelligently, guided by evidence rather than assumption. Testing policies without breaking traffic is a critical step in safe rollout. CloudArmor supports preview modes where administrators can evaluate how a new rule would behave before enforcing it. This approach allows teams to observe potential blocks or false positives without affecting live users. Once confidence builds, the rule can transition to enforcement seamlessly. A common practice is to simulate WAF policies during development and review logs to confirm correct behavior. Controlled testing prevents security from becoming disruption. It turns policy deployment into a repeatable, low-risk process that encourages experimentation and continuous improvement rather than reactive firefighting. Incident playbooks define how to detect, block, and verify during live attacks. CloudArmor provides the technical foundation, but process and readiness determine success. Teams should maintain documented steps for activating emergency rules, monitoring effectiveness, and validating recovery. For example, during a distributed denial of service event, the playbook might include enabling stricter rate limits, reviewing adaptive protection insights, and confirming application availability through synthetic monitoring. Post-incident analysis helps refine future responses and adjust thresholds. Practice procedures transform chaos into coordination, ensuring that every alert leads to clear action. The tool provides capability, disciplined response makes it effective. Cost and performance considerations guide how CloudArmor fits into a broader architecture. While filtering adds minimal latency, policy complexity and logging volume can influence overhead. Administrators should balance the depth of inspection with business requirements, focusing on high-risk endpoints first. Pricing typically aligns with request volume, meaning optimized rule sets not only improve performance but also manage costs. For instance, grouping similar paths or consolidating redundant policies reduces evaluation load. Because CloudArmor operates at Google's global edge, it offloads computation from back-end servers, often improving total throughput. Efficient policy design therefore enhances both security and user experience while keeping budgets predictable. Real-world scenarios demonstrate how CloudArmor's safe defaults protect even before customization. Enabling standard managed rules immediately guards against common web attacks, while adaptive protection detects unusual spikes without manual configuration. A startup deploying its first public API gains protection from day one, while an enterprise can layer CloudArmor into complex architectures with minimal disruption. Safe defaults do not replace tailored defense, but ensure every service begins from a strong baseline. Over time, teams can expand and refine policies as understanding grows, evolving from generic protection towards specialized resilience suited to their unique traffic patterns. CloudArmor represents one layer in a broader security perimeter built on observability and adaptation. Its value lies in filtering and insight-seeing threats early, acting automatically when possible, and integrating response with broader cloud operations. No single control guarantees safety, but together with identity, encryption, and governance, CloudArmor completes the picture of layered defense. By minimizing exposure and coupling visibility with automation, organizations protect not just their networks, but also their reputation and customer trust. The future of security is not walls, but awareness, and CloudArmor delivers that awareness at the edge of the global network. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.